Example 4.2, use superposition to find the current Ix through the 20K resistor. Superposition states that Ix is equal to the superposition current of each individual source through the 20K. So that means here is that Ix is going to be due in part to the 12-volt source produced to the 20K plus the 3 milliamp source plus the 9 milliamp source, all through these sources here. So now what I'm going to do here is I'm going to take each of the individual sources. So I'm going to start with the 12-volt source. Contribution to Ix. So that means here is that we have to deactivate the 3 amp and 9 amp current sources. So let's do that. So that means to deactivate them, I got to create opens. So here I go. So I'm going to go and I'm going to keep my 12-volt alive. But now I have to open the 3 milliamp and I have to open the 9 milliamp source. So if I look at this guy, this is going to be my 20, my 4, my 12. And so if I look at the current, you could see here is that the current through the 20 ohm, according to our directions from the circuit, you could see here is that Ix is going in that direction. So that means that the current of the 12-volt source has to be going in the same direction as Ix. While you could see here that this is a series circuit, which means I'm going to use Ohm's law. So that tells me here, so if I look at that 12-volt, the first thing you got to note here is that this is going to be in the opposite direction of the source current, because you could see that the source current is coming in that direction. So now, according to this, I have 3 resistors in series, divided into my source, and that's going to give me minus 1/3 milliamp for the current of the 12-volt source. So here's my first contribution. So my second contribution is going to be through the 3 milliamp source. To Ix, which then means I have to deactivate the 12-volt and the 9 amp sources. So that means here, so I keep the open with the 9 amp and the 12-volt is now going to be a short. So here we go. So I'm going to go, there's my 20. This is now a short, but this time I'm going to activate my current source. And that's my 3 amp source. And then I have my resistor. And then of course I have my open right here for the 9. So again, this is 4, this is 12. Now, according to our directions here, this current should be going in this direction for IX. So therefore, this is my 3 milliamp current contribution. So you can see here is that this is a parallel circuit. So I'm going to use CDR. So if I want the current of the 20 ohm, it's got to be the opposite resistance. And that's going to be, the opposite is going to be the 4 plus the 12, and then divided by the sum. And then this is a 3 milliamp source. So when I calculate this, I'm going to get 4/3 milliamps for my contribution from the 3 milliamp source. So now the last one that I have to talk about is the 9 milliamp. So this is going to be my 9 milliamp source contribution to IX. So what do? I have to deactivate the 12 volt and the 3 milliamp sources. So if I look at my circuit here, it's going to look like this. I have a short. I now have an open. And then I have my 4 ohm. I have my 12 ohm. And now I'm going to contribute with the 9 milliamp source in this direction right here. So again, this is my 12, this is my 4, this is my 20. And in this case here, we see that the current is going like this. So this is going to be the 9 milliamp contribution. And you can see that it's going to be opposite of the 9 ohm source here, 9 milliamp source that is. But either way, it's still a parallel circuit, right? So this is still a parallel circuit. So that means I'm going to use CDR again. So if I want the contribution of the 9 milliamp, I immediately see that it's got to be opposite the direction of the source. So then it's got to be the opposite resistance. So you can see that the 4 and the 20 are the opposite resistance. Are the same resistance. So then this has to be 20 plus 4 plus 12. 12, and then I'm going to have my 9 milliamp source here, which then gives me minus 3 milliamps, and this is going to be the contribution of this guy right here. So now if I look at if I apply superposition now, I have my circuit. So what's my circuit? So I have a 20. I have a voltage source. That's 12 volts. I have a current source. That's 3 milliamps. And then I have the same resistor contribution, but now I have my 9 milliamp. So this is 4, this is 12, this is 20. So what we know here is that we have a current. What is this current? I have a current called IX. But what we know here is that this IX is equal to what? I have a green current going like this, which produced by the 12 volt, plus I have my blue current due to the 3 milliamp, plus I have my current in the red that's in the opposite direction due to the 9 milliamp. So when I look at this thing, if I look at this tells me here is that then from superposition, it's got to be I of 12, which is minus 1/3. Then the blue is 4/3. And then the red is 3. So if I add these up here, I'm going to get 2 minus 2 milliamps for IX, which is the same as the 20K.